So let us learn about electric lines of force. If this is a positive charge, then the direction of electric field, that is electric lines of force, will be radially outwards. Okay, the lines of force are straight and they are radially outwards. If it is a negative charge, then the lines of force are again straight and are radially directed radially inwards towards them. So here the lines of force are drawn in the field produced by two equal and opposite charges at a small distance. Okay, these lines we can see is originating from the positive charge and it is terminating on the negative charge, and the concentration of the lines is greatest in the region between the charges, okay, where the electric field is strongest. The electric lines of force are drawn in the field produced by two equal and similar charges, if suppose it is positive charge, and at the midpoint n of the line joining the two charges, the field produced by one charge is equal and opposite to the field produced by the other charge. Therefore at this point the resultant field will be 0, that is at n. This point is called as neutral point. So if we keep a test charge at this neutral point, then the test charge will have no tendency of motion in any direction because the force is 0. As we move far from the charges, the lines of force are becoming radial, and it is like a characteristic of a single charge. Electric dipole. A pair of equal and opposite point charges placed at a short distances apart. It is called as electric dipole. So here there is a negative charge minus q and here it is a positive charge plus q, which both the magnitudes are equal. If this is minus 5 coulomb, this should be plus 5 coulomb, and the distance between them is 2l. Okay, this we can even take it as a, but here we are writing it as 2l. The distance between them is 2l. Then this constitutes a dipole. Okay, and what is the direction of dipole? Please remember, its direction is from negative charge to positive charge. So here it is in this direction towards right side, because from the negative charge towards the positive charge, it is a vector because it has some direction. And here one more condition is their algebraic sum of charges should be 0. So plus q minus q equals to 0. So what is the formula for dipole moment? That is equals to q into 2l. So this can be written like total type of one charge into distance between the centers of positive and negative charges. Please see, here we are writing either charge, whether it is magnitude of plus q or minus q, it is going to be q into the distance between them is 2l. Okay, if the distance between the plus q and minus q is a, then you should not write 2a. Q into a must be written, but here it is 2l, so it is q into 2l. That is what I have shown here. Let us learn one more thing. Three charges minus 2q plus q and plus q at corners of isosceles right triangle form dipole because minus 2q plus q equals to 0. So what I have told, so here there is a charge minus 2q at A and it is B, it is C. The distance AB equals to BC. Okay, it is a right angled isosceles triangle, and at B and C we have positive charges plus q, and the A we have minus q charge. Now this forms a dipole because the net charges, the algebraic sum of the net charge, that is 0. So it is a dipole moment. And how do we calculate the net dipole moment? So please see that. So this is the dipole. I can assume minus 1q and minus 1q because on addition we are going to get minus 2q only. So this minus q and this plus q will be one dipole, and this minus q and this plus q will be another dipole. So what will be the direction? So I am splitting this, okay, like this. This minus 2q I am splitting it like minus q and minus q. So this minus q and plus q is forming one dipole, and this minus q and plus q forming another dipole. So this direction is from minus q to plus q, so it is in the direction like this, and its direction is towards right side. Okay, because it is directed from minus to positive charge, so it is this like this. And if this side AB equals to, we know AB equals to AC because it is a isosceles triangle. If suppose that distance AB or AC that is equals to A, then we can say this is A, this is A. Okay, I hope you got it. So this can be taken as like a vector addition. So this one, this dipole moment is like this, and this dipole moment is in this direction. They are at right angles to each other. So if this is AC, one dipole moment, and this is another dipole moment, so they are at right angles to each other. Okay, so the resultant will be in this direction. Okay, so please see, here it is, here the minus is there and here plus is there, so its direction is from minus to plus. So its direction is from minus to plus. So even the net dipole moment, it will be directed from A to D, from minus to plus. Okay, it is from minus. Okay, that is what you have to understand. Now let us see how we are calculating the net dipole moment. It is it have already shown, it is root 2 into QA. Let us see how it is. We know net dipole moment equals to under root p1 square by p2 square plus p2 square. So here it is also p1 and here also it is p1 only, because the distance is also same in both the cases and the charge is also same. So the dipole moment in these two cases are same. So under root p1 square plus p1 square, so that is equals to under root 2 p1 square. So it is under root 2 p1. So that is what I have shown. What is p1? P1 is nothing but Q into A. Why we are writing Q1 into A? Please see, if this is minus Q and this is plus Q, I have told it is either charge into distance between the charges. Either charge means it is Q only. Distance between the charges A. So it is root 2 QA. So that is what I have told. So that is the net dipole moment in this case. Electric field due to dipole. So now let us see how we are finding electric field due to the dipole in axial position and in equatorial position. So what is an axial position? So if this is the dipole and if the point is along the line on the dipole, then it is an axial position. What is the formula for finding electric field? I have just shown the final result and it is just enough for doing problems. So this 2L is the distance between the charges, and this R is the distance of the point for which we are interested in finding the electric field from the center of the dipole, that is R. So E equals to 2 kpr by r square minus l square whole square. So K is nothing but 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught kpr, I have missed 2 by r square minus l square whole square. So if it is a short dipole, means if r is much greater than this l, okay, if the length of this dipole is very small, then we can ignore the length l, okay, then it will be r square whole square. That means it is r power 4. So this r and r power 4, one r goes, so it is kp by r cube. So the formula becomes 1 by 4 pi epsilon naught 2p by r cube. So this is how the formula for electric field at the axial position because of dipole we get. So if this is the electric dipole, now let us see about the equatorial position. If our point is located in the perpendicular bisector of our dipole, then that point is called as equatorial point. So this is the equatorial line. Okay. Now again, this is the length of the dipole, that is 2L, and distance of the point from the dipole is R. Okay, so what will be the electric field? Electric field equals to 1 by 4 pi epsilon naught P into R square plus L square whole power 3 by 2. So this is the general formula. And in case of short dipole, when R becomes very larger than L, then what is the case? Then this will be the case, E equals to 1 by 4 pi epsilon naught P by R cube. Okay. Actually, this L square goes, so it will be R square whole power 3 by 2. So this 2 and this 2 goes. So it is R cube. So that is what we have shown it here. And now let us learn About the direction of electric field because of the dipole in axial and equatorial position. First, please remember, for axial position, the direction of electric field will be along the dipole. Okay, along the direction of dipole. If you take equatorial position, the direction of electric field will be in the direction opposite to that of dipole. Now let us see that. So we have also we should note E axial equals to minus 2 times E equatorial, because you please see this one. This is E axial, this is E equatorial, and if we are multiplying this with 2, then we get E axial. So that is what I have shown it here. Okay, and also one more thing, for short dipole we can see E is inversely proportional to R cube. That is, E is inversely proportional to R cube. That also we should note. Now let us see about the direction. So this is our dipole minus q2 plus q. Its direction is towards right like this. Now this line is axial line and this line is equatorial line. Now let us see what is the direction. I have told, if this is the direction of dipole, on axial line the direction of electric field will be along the direction of dipole. Whether you take on the left side or right side of the dipole, the direction of electric field is like this only, that is along the direction of dipole. If you take equatorial point, whether it is above this one or below this one, it will be in the direction opposite to that of dipole. It will be in this direction. At this point, if you take the electric field, it will be in this direction. On the equatorial line, it is same. If you take even this point, then it will be in this direction only, because in the direction opposite to that of dipole, the electric field will be directed. Now let us see what is the formula for finding electric field in random direction in some point other than equatorial or axial point. So the general equation is 1 by 4 pi epsilon naught p by r cube into under root 1 plus 3 cos square theta. So please note here p is nothing but dipole moment, that is 2 into q into L. So this is the general formula. Now here what is theta? If suppose this is the case, minus q, and here it is plus q, and if suppose this is the point we were finding the electric field, then this is theta. Okay, this point, and what is the angle it is making with the dipole, so that is theta. Please note that one. So if you want, you can substitute theta equals to 0 or 90 degree, then you will be getting the formula for electric field at axial and equatorial position. So it is a general formula. Okay, please remember this point also. And here this is theta, and if this is so this we generally solve into components. Then the E axial will be in this direction, E equatorial will be in this direction, and E resultant will be making an angle alpha with the E axial. Then what is the relation between tan alpha and tan theta? That is tan alpha equals to half into tan theta. So please note that one also.